Hello there, Algebra 2 students. Mr. Weber here. Today we're going to talk about something called the Pythagorean identity. And we're going to use it to find the sine or a cosine of an unknown angle. And you're going to see what I mean by this in just a second. I want to remind you that this can be found in pages 374 to 380 in your textbook. So if you do have questions, you can go look there. Before we get started with this, though, I want to say one thing. Just in me reflecting on years past, this has been a topic that students either love or not. And here's what I'll say. If you're a person that is really tired of looking at graphs and you love like solving equations, then you're going to love this. This is right up your alley. If you're one that would rather look at a graph and find key features of a graph than to solve for x, then you're going to struggle maybe with this. But here's what I will say to both of you, both types of students, whether you are going to love this or you think you're not. We're going to be doing the same thing every single problem. So you'll need a calculator today, and I want you to get used to the steps that we're doing, because know that this is one of those topics where they're going to look pretty much the same. You're going to ask yourself the same questions, and you're going to do the same thing over and over and over and over again. Not every topic is that way, but this one is. Okay, so knowing that going in can really help you when you get stuck. All right, so what do you need for today? Here's the first thing you're going to have to think about. Let's think about our unit circle. All right, let's think about the unit circle in terms of radians. All right, let's step around this unit circle in terms of radians. Not all the way, just at the poles. Okay, so we start off at 0 radians, and if we go all the way around, we know that's 2 pi radians. If we go up to 90 degrees, what's 90 degrees in terms of radians? Pi over 2. If we take another pi over 2 step, we're at single pi, then 3 pi over 2, and lastly at 2 pi. Okay, so far so good. Just going around the circle in terms of radians. Now, next, let's think about what quadrants are we in. Well, if you're in that positive quadrant, remember that's quadrant 1, and it goes counterclockwise. So there's quadrant 2, quadrant 3, and quadrant 4. Okay, the last piece we're going to need to know is what are the signs that correspond to each of those quadrants. If we're in the first quadrant, remember everything's positive, positive, positive. If we're in the second quadrant, well then x is negative, but y is still going to be positive. If we're in the third quadrant, everything's negative, and in the fourth quadrant, x will be positive, y will be negative. Okay, that's kind of like the basis that you're going to need for today's lesson. You're going to have to kind of understand that and know that in terms of solving this. And if you can get this, and if that makes sense, then you're at a good place to start off with. If not, you might want to go back and look at some previous lessons to get caught up. Okay, here we go. Let's jump into it. We only have 4 problems today. All right, so hopefully it's easy peasy. Here we go. Some notes. All right, let's start with the Pythagorean theorem, because the Pythagorean theorem shows you the relationship between the sides of a right triangle. What is the Pythagorean theorem? I know it's so hard to remember. A squared plus b squared equals c squared. Remember, A and B are the legs of a right triangle, and C is the hypotenuse. Okay, so let's express this relationship in terms of the unit circle. So if we look at it, we'll start with Pythagorean's theorem, which is a squared plus b squared equals c squared. Okay, let's rewrite this based on the unit circle. Okay, so if we wanted to think about this in terms of the unit circle, what is A? Okay, so A could be x, B could be y, and C could be 1. So I could say, instead of a squared plus b squared equals c squared, in terms of the unit circle, it'd probably be better if I said x squared plus y squared equals 1 squared. Does that make sense? Remember our x distance here? This horizontal distance here, that's our x distance. It's the same as this distance here. The y distance is the same as our vertical distance. So we have that right triangle, and then our hypotenuse is 1. Okay, x squared plus y squared equals 1 squared. Let's rewrite that in terms of sine and cosine. Remember, the x value is the cosine, the y value is the sine. All right, x value is the cosine, y value is the sine. So I could rewrite this as cosine theta squared plus sine theta squared equals 1 squared. So far, so good. Okay, now here's the thing. We think about this cosine theta squared with the way we've written it. We just wrote it with cosine and theta and then the square on the outside. But there is a notation when you deal with sine and cosine where they take that square and they put it right next to the trig function that looks like it's inside of this angle. It looks weird, all right? But you have to know that this is the exact same thing as this right here. They mean the exact same thing. They're just written differently. Okay, so if we rewrite it the way that it's written, we could write it like this. Sine squared theta plus cosine squared theta equals 1. Notice I did one thing extra, is I flipped the order of x and y, just because for some reason, this is the way, if you look it up in a textbook, this is the way you're going to see it. Okay, so you're going to see it this way in a textbook, so I flipped that cosine and sine. All right, so far so good. So this is the Pythagorean identity. It's based off the Pythagorean theorem. If you know a squared plus b squared equals c squared, that's the same thing as saying sine squared plus cosine squared equals 1, because it's all based on the unit circle. All right, 1 is the hypotenuse, 1 squared is 1. X is cosine, y is sine, and so it's right there. Okay? All right, so here we go. 4 examples. Here's problem 1. Given that cosine of theta is negative 3/5 and pi over 2 is less than theta, which is less than pi, find the value of sine theta. Right off the bat, that sounds like there's a lot there, and you might not know how to do this. All right, so you might go to your unit circle and say, let me just find cosine of negative 3/5, and then I'll just figure out what the sine value is. There's a problem with doing that. And that is 3/5 does not appear at all on our unit circle. All right, so this is the reason why we need to know the Pythagorean identity. We've encouraged you to memorize or to remember as many of those points on the unit circle as you can, so you don't have to do much math. You can just look at the unit circle, you can know where it is, and know what the sine or the cosine was. But sometimes you get an angle that's not one of those 30, 45, or 60-degree angles. It's a different angle. It still has a ratio of sides. It still has a value for sine and cosine. It's just not one of the ones that we've memorized. And that's where the Pythagorean theorem, the Pythagorean identity comes into play. Is when you have the cosine of one angle, or the sine, and you want to find the other one, how do you do that? And here's how we do it. Okay, so the first thing that we're asked is what quadrant does theta fall into? So this is why we got to remember what we just talked about up top. All right, so if we look at this, they tell us that theta is in between pi over 2 and pi. You see that? Now go to your unit circle. Where would that angle have to be if it's in between pi over 2 and pi? It'd have to be right here. And somewhere in between pi over 2 and pi, which puts it in the second quadrant. Okay? Now, here's the key thing. We're in the second quadrant. We're asking you about sine. Sine is the y value. So what's sine going to be in the second quadrant? Positive. Positive. So far, so good. Okay. All right, here we go. Get ready. Here comes the algebra. All right, we're solving equations. We're going to start with our Pythagorean identity. Sine squared plus cosine squared equals 1. All of these are going to start the same way. Okay, let's think about what we know. They always are going to give you one. In this case, they give us cosine. They say cosine is negative 3 over 5. So plug in negative 3 over 5 for cosine. All right, so now we have sine squared of theta plus negative 3/5 squared equals 1. Okay, on the left here, beside this line, I'm just going to do some scratch work over there. So the right is kind of like our answer. The left is kind of like some scratch work that I'm going to use to get the answer. And the first bit of scratch work I'm going to do is to figure out what is negative 3/5 squared. Okay, so now remember, anytime you square any term, you're just multiplying that term by itself. Okay, so it's negative 3 over 5 times negative 3 over 5. All right, let's think about what that is. All right, so first things, we have a negative times a negative. So answer is going to be what? Positive. All right, now we multiply straight across. 3 times 3, 9. 5 times 5, 25. All right, so negative 3/5 squared is equal to 9 over 25. Okay, so far so good. Let's rewrite it. Sine squared of theta plus 9 over 25 equals 1. So far so good. All right, now let's do some algebra. We want to figure out what sine is, so we got to get sine squared by itself. So what do we have to move? We got to move that 9 over 25. So do the opposite of what you see. It's a positive 9 over 25. So I'm going to subtract both sides by 9 over 25. But there's a problem. We can't subtract 1 and 9 over 25 because they don't have the same denominator. What are we going to do? Remember, 1 is like a wild card. You can rewrite 1 any way you want. Think about it. What's 10 divided by 10? 1. What's 50 divided by 50? 1. What's 6,725,000 divided by 6,725,000? 1. Anytime you multiply the top and the bottom by the same number, the answer is always 1, which means we can take the number 1 and we can rewrite it as any fraction that we want. What do we want? We want the denominator to be 25. So I'm going to change 1 to 25 over 25. All right, still 1, right? But now I have the same denominator, and I can go to my scratch work, and I can say, let's just subtract 25 minus 9. 25 minus 9 is 16 over 25. So that means, bum, bum, sine squared of theta is 16 over 25. Are we good? Are we done? No. I don't want sine squared of theta. I want sine. How do I do that? Well, you take the square root. And when you have a fraction, you're going to take the square root of the top and the square root of the bottom. So sine squared of theta is the square root of 16 over the square root of 25, which is 4/5. So now we're done, right? Not necessarily. We got one extra step. We have to go all the way back to the top and ask ourselves, what quadrant are we in? What sign should this answer be? And it should be positive. All right, so we're not done till we say the answer. Sine of theta is positive 4/5, because that positive comes from the fact that it's in quadrant 2, and in quadrant 2, sine's always positive. I get that, Mr. Weber, but I don't know why we have to do that. Okay, well, they're telling us that the angle has to be between these two things. So in this case, it didn't really matter because it was positive. But there'll be some cases where we know that our answer is going to have to be negative. Now, the math that we do will never end up with a negative answer. It's our job to put that positive or negative in at the end after we've done all the algebra. Let's look at example 2. Oh, numbers are bigger. You're going to need a calculator. If you don't have one, pause it right now. Go find one. All right, so sine of theta is negative 40 over 41, and pi is less than theta, which is less than 3 pi over 2. Find the value of cosine of theta. All right, so let's go back to what we had, our trusty little remembering device. I don't know what you call that, picture, unit circle. All right, so here we go. What quadrant are we in? Well, we know theta has to be between pi and 3 pi over 2. So where is that on the unit circle? It's right there. So we are in quadrant 3. Okay, now what are we asking about? We're asking now about cosine. So what's cosine? Cosine is the x value. The x value is negative. So far, so good. Guess where we're going to start? Same identity. Sine squared plus cosine squared equals 1. Now, what did they give us in this problem? Well, in this problem, they told us that the sine of theta was negative 40 over 41. So let's plug that in. Negative 40 over 41 squared plus cosine of theta equals 1. All right, what is negative 40 over 41 squared? Well, remember, just multiplying it times itself. A negative times a negative is a positive, and you multiply straight across. Okay, so this is where you're going to need a calculator. 40 times 40. These numbers are going to get big. Okay, don't be afraid, one, of the fraction, and two, don't be afraid of the big number. Okay, you have a calculator. We expect you to use it. Okay, so 40 times 40 is 1,600. 41 times 41 is 1,681. All right, so we get 1,600 over 1,681. It's a big fraction. All right, it's big numbers. But that's okay. We can deal with it. We can do it. Let's just keep going. I did that backwards. Mr. Weber. This should say cosine. All right, so cosine of theta plus 16 over 1681 equals 1. We're going to subtract both sides by 1,600 over 1681. But we got a problem. We got to change 1 into a fraction. What do I want that denominator to be? 1,681. So what are you going to change 1 to? 1,681 over 1,681. Mr. Weber, this is crazy. All right, well, if you don't want to do that, if you have a calculator, you could probably use 1 minus the fraction, and it will probably do it for you. But just in case it doesn't, let's do it by hand. 1681 minus 1,600 over 1681. So we're just going to subtract the numerators. The denominator stays the same. And we get 81 over 1681. All right, that is cosine squared. Now, how are we going to find our answer? Square root, top and bottom. Square root of 81 is 9. And the square root of 1,681, that has to be 41 because that's how I got it, because I multiplied these two numbers together. So it's 9 over 41. Are we done? No. This is what I was talking about just a second ago. Look where we are. We know that we're in quadrant 3, which means that we know that because we're talking about cosine, we know that this answer here should be negative. So, because we know it's negative, our answer is the sine of theta has to equal negative 9 over 41. And that's just because they're telling us that this angle is residing somewhere in this quadrant. It's something like this. So far, so good. If you really feel like you know what you're doing, I encourage you to pause it, try 3 and 4 on your own, and then hit play and see if you're right. Okay, here we go. Number 3. Cosine of theta is 15 over 17. 3 pi over 2 is less than theta, which is less than 2 pi. Find the value of sine of theta. All right, so we go to our unit circle. We're now looking between 3 pi over 2 and 2 pi. So what quadrant are we in? We're in quadrant 4. Okay, so that means that if we're looking for sine is the y value, so the y value here should be what? Negative. All right, good. My answer should be negative. If this is a multiple choice test, sometimes you can get half the questions to go away just by knowing what the sign's going to be, if it's positive or negative. All right, so we're starting with our Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. All right, that is the Pythagorean identity. Easy peasy. What do we know? Well, we know cosine of theta is 15 over 17. So sine squared of theta equals 15 over 17 squared equals 1. Well, what is 15 over 17 squared? All right, well, we're going to multiply 15 over 17 times 15 over 17. We're going to grab our calculator. We're going to multiply straight across the top, straight across the bottom. 15 times 15 is 225. 17 times 17 is 289. Okay, so there we go, 225 over 289. So far, so good. All right, here we go. So that means that sine squared of theta plus 225 over 289 equals 1. All right, so what are we going to do? We're going to subtract 225 over 289 from both sides. Whatever we do to one side, we've got to do to the other. All right, remember 1 minus, so we got to change that 1 from a whole number to a fraction, and that fraction has to be a denominator of 289. So here we go, 289 over 289. We're going to multiply 289 minus 225, and we're going to get 64 over 1,681. All right, so I'm just doing, like, I know the numbers are big, but think about what you're doing. You're really not dealing much with that fraction in your calculator. What you're doing is you're multiplying like 15 times 15, 17 times 17, and then you're subtracting 289 minus 225. These are all operations that are pretty straightforward, even though it looks like we're doing a lot of complex math with fractions. If you think about how you have to use your calculator to find these answers, you're not doing a lot of fraction work. It looks like fraction work, and it is, but you're really doing a lot of that whole number integer addition in the numerator. So now we get sine squared of theta equals 64 over 289. What are we going to do now? Square root. Square root of 64 is 8. Square root of 289 is 17 because that's where it came from. So sine of theta equals 8 over 17. Are we done? Nope, 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 nope. All right, last step. Last step, we got to go back and figure out what quadrant we're in. What quadrant are we in? We're in quadrant 4, which means sine has to be negative, so our answer has to be negative 8 over 17. If I was building a test, you can guarantee I'd put the positive value there, and I'd expect you to half of you to put it. Don't fall for that mistake. All right, look at what quadrant you're in. Make sure that your sign is always what it should be. Huh, that was a little pun. I didn't even realize it. Your sign. Huh. Whoa. All right, here we go. One more. Example 4. Given that cosine of theta is negative 28 over 35, right off the bat, these are big numbers. So we're going to get big numbers when we do this. Don't be afraid of that. Pi over 2 is less than theta, which is less than pi. Find the value of sine of theta. All right, so here we go. There's our unit circle. We're looking for pi over 2 and pi. So we're in between pi over 2 and pi. So what quadrant are we in? We're in quadrant 2, which means what? We're looking for sine. Sine is the y. So we're going to look for a sine, which means we're looking for something that's positive. All right, start with your identity. Pythagorean identity is sine squared theta plus cosine squared theta equals 1. What do we know? We know that the cosine of theta is negative 28 over 35. So we got to square that. Negative 28 over 35. Here's where you need a calculator. All right, negative times a negative is going to be a positive. Now let's multiply straight across and hope we don't type this in wrong. 28 times 28 is 784. 35 times 35 is 1,225. That's a crazy fraction, but it is what it is. Don't worry. Go with it. All right, sine squared of theta plus 784 over 1,225 equals 1. Okay, now what do? Well, we got to get sine squared by itself. All right, so we're going to subtract that 784 over 1225 from both sides of our equations. I want this part to cancel out so that I'm left with sine of theta. I can't do this because one's a whole number and one's not. Remember, you can change one to anything you want. So we're going to change it this time into 1,225 over 1,225. I'm just doing that to make my denominators the same so I can do that subtraction. 1,225 minus 784 is 441. All right, so sine squared of theta equals 441. And now we can take the square root of the top and the bottom. Ends up being 21 over 35. Done and done? Not necessarily. What's our sign here? Our sign has to be positive. So our answer is positive 21. No, it's not. How did I get 3 over 5? Well, look. This can be simplified. So the key is, at the end of the day, if you can simplify, you do simplify. So if I divide the top and the bottom by 7, 21 over 35 is 3/5. So the best answer to put would be 3 over 5. If it's not multiple choice, if it's free response, we would probably take either one because they are the same, but we would encourage you to simplify when you can. Okay? That's it. That's all you're going to do. Every single problem, you're going to start off by thinking, okay, what quadrant am I in? Okay, is that value going to be positive or negative? That's why you need to know the quadrant. Then you're going to think about your Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Plug in the value that they know, that they give you, and then you're just doing algebra. You're squaring it, you're subtracting it, you're taking the square root to find the other trig function. Okay, and that's it. It's a lot of steps, but we're doing the same thing over and over and over and over again. Okay, if you have questions, please don't hesitate to reach out to your teacher. We're always here to help. And keep doing what you're doing. I know it's hard. You guys have put a lot of hard work in. We know that you have. Keep doing what you're doing. You're doing great. And let us know if we can help you out any step along the way. All right, good luck. Have a good one.